Okay, so you see here, starting from here, central bright fringe, as we go up or go down, you can see the path difference increases. Yeah, of course, as if we starting from the central bright fringe, we go to one side, the path difference, one of the wave have to travel even longer and longer distance, isn't it? Because we go up, let's say we go up, yeah, from the central bright fringe, we go up, the S2 have to go even further distance. Yeah, if you compare, like for example, we compare this one and this one. Yeah, compare to here. We compare these two. We compare the first and the second. The first wave, the path difference is, let's say, half lambda. But the second wave, of course, is the path difference is not just half lambda, because the S2 have to travel even longer distance compared to the first position. Okay, so this one, of course, we can say the path difference for the first one, of course, it is lower. Of course, it is we can say, of course, it is lower compared to the path difference between for the second one, yeah, which is even higher. Okay, so okay, just want to show you that. Okay, you see, starting from here, yeah, from the center, of course, has no path difference because they have the same length. Yeah, S1 and S2 have the same distance to reach the central bright fringe. Yeah, have the same distance, so no path difference. That's why it's 0 lambda. Yeah, starting from here is 0 lambda, and then go up is become half lambda, and then go even higher is 1 lambda, and then go up higher is this is 3/2 lambda. 3/2 lambda actually is 1 plus half lambda. Actually, this is considered 1. This is actually 1 plus half lambda. Yeah, 1 plus half lambda. Okay, I should write even better here. 1 plus half lambda. Yeah, and then we have 2 lambda, and then we have the next one. What do you think? The next one should be 2 plus half lambda. Yeah, the path difference, you see, and then the next one should be 3 lambda, and then so on. So if you look over here, that's why whatever it is multiples of lambda, like this one is 0 lambda, 1 lambda, 2 lambda, maybe I should highlight. Okay, I should highlight it. Whatever it is 0 lambda, 1 lambda, you see that? 1 lambda, 2 lambda, and then of course a 3 lambda. Okay, whatever follows the pattern of m lambda, 0 lambda, 1 lambda, 2 lambda, whatever follows a pattern of m lambda, they form a bright fringe. The m can be substituted with 0, 1, 2, 3, and so on. So whatever it is 0 lambda, 1 lambda, 2 lambda, they all form bright fringe. Can you see that? They form all central bright fringe, first bright fringe, and second bright fringe. That's for in-phase sources. That's for in-phase sources. They all form bright fringe. But whatever it is follow the patterns of half lambda, 1 plus half lambda, 2 plus half lambda. Yeah, half lambda actually is 0 plus half lambda. Whatever that has a half there, they all form dark fringe. They all form dark one. You see that? You see the half lambda form dark first dark, 1 plus half form the second dark, and then 2 plus half lambda, of course, form the third dark. You see that? I should highlight it. Okay. Okay. See the half lambda, second half lambda, and then the second dark is the 1 plus half lambda, and then we have a second half. We didn't draw here. So that's why it form a zebra line. Okay, that's the reason it form a zebra line on the screen. Yeah, you see this pattern. This is what we call interference pattern. Okay, that's the thing. Okay, so we can say as we go up, whatever it is going up, or going down, the delta L is increasing. Is increasing, or going down, the delta L always increasing. Yeah, go up or go down, the delta L always increasing, because one of the wave had to travel even longer distance. So when go up the screen, go down the screen, the fringes changes from bright to dark, from bright to dark, yeah, because it follow this one. Is from switching from m lambda to m plus half lambda, and then back to m lambda, and then back to m plus half lambda. That's how it works. Understand? Okay, so we have talked about in-phase sources. Okay, in-phase sources, to form the bright fringe, the path difference must be multiples of lambda, m lambda. To form the dark fringe is m plus half lambda. But for antiphase sources, what is antiphase? Means like this, yeah. We start off with opposite direction. So for antiphase sources, this path difference become opposite. Become opposite. That means the m lambda used to be bright fringe. Now it becomes for dark fringe. The m plus half lambda used to be dark fringe. Now become for the bright fringe. That is what happens to antiphase sources. So you see, for in-phase sources, for in-phase, you see that for in-phase sources, the bright fringe used to be m lambda. Okay, but for antiphase sources, the bright fringe become m plus half lambda. The m lambda now belongs to dark fringe. That's how unfortunate. But for in-phase sources, last time the m plus half lambda used to be for the dark fringe. Yeah, for in-phase sources, the dark fringe used to be m plus half lambda. Now for the antiphase, the dark fringe use m lambda. Antiphase, the dark fringe use m lambda, and the m plus half lambda now belongs to bright fringe. Yeah, this is we already explained about this path difference before. Okay, we already compare. You see that? Last time we talked about for in-phase source, the bright fringe is using m lambda. Yeah, the bright fringe use m lambda. But for antiphase, the bright fringe now use m plus half lambda. Just look at what happened. You see, this antiphase source. Let's say there's no path difference. Yeah, there's no path difference. Start off with antiphase already, end up also antiphase. The path difference is 0 lambda, isn't it? 0 lambda, which is dark fringe. So 0 lambda, 1 lambda, 2 lambda, 3 lambda, which is m lambda. M lambda is now used for dark fringe. It form a dark fringe because they destructive interference for antiphase. M lambda, last time m lambda is for bright fringe. For in-phase source, m lambda is for bright fringe. Now m lambda is for dark fringe for antiphase. But how about the next one? Like this one, you see, I start off with antiphase. Yeah, the first wave have extra distance of half lambda. Okay, half lambda. So the path difference is half lambda. They end up constructing interference to form a bright fringe. So when path difference is half lambda, it form a bright fringe. 1 half lambda, 1 plus half lambda, 2 plus half lambda, 3 plus half lambda, m plus half lambda, it form a bright fringe for the antiphase source. For the antiphase source, m plus half lambda for antiphase source. Okay, you see that? That's the difference. So what I can say conclusion. What I can say conclusion is just see the difference. Just see the difference. Yeah. So for in-phase source, the central is a central bright fringe. You see that? Central bright fringe. You see, because when no path difference, when the path difference is 0 lambda, we start off with in phase, end up also in phase. You see that? End up also in phase. Of course, it form a bright fringe in the end. Yeah, constructive interference. But for antiphase source, they start off with antiphase, end up also with antiphase. end up with antiphase, form a central dark. Last time used to be central bright, now become the central dark. I should use a blue color. Central dark already. Central dark already. Okay, you see that? When delta L is 0 lambda, you see the central dark. Actually, for central dark is 0 lambda. You see that? Central dark is 0 lambda. 0 lambda is central dark. So of course, the next one, 1 lambda, 2 lambda. Okay, 0 lambda is central dark already. So 1 lambda also dark lah. Multiples of lambda is multiples of lambda. 0 lambda is dark. That means 1 lambda also dark. 2 lambda also dark. So the one with 1 plus half lambda got half lambda. 1 plus half lambda, 2 plus half lambda become the bright. So just the opposite to the in-phase source. You see that? So you see, it becomes opposite. Last time it start off with central bright, yeah, bright, dark, bright, yeah. Now become the dark, bright, dark, yeah, become opposite. Bright, dark, bright. Now become dark, bright, dark. It become opposite. The zebra line also become opposite. Okay. So like this lah. See. So when you see, when it is an antiphase source, when for 0 lambda, okay, for 0 lambda, they end up also antiphase. So we form a dark fringe. So we form a, this is what we call the central dark fringe. Central dark fringe. So and then going up even higher, going up one step higher, going up one step higher. Okay. For 0 lambda already form central dark. That means the next one should be 1 lambda. Okay, the next one should be just wrap off this part. The next one should be the next part should be yeah, 0 lambda. The next one should be 1 lambda. Yeah, 1 lambda. The path difference is delta L equal to 1 lambda. That one will form the path difference. The delta L now is 1 lambda. That one will form the first dark fringe. You see that? First dark fringe. So that's the thing lah. Yeah, first dark fringe. But for the if the difference is you see like this one, the difference is half lambda like this one. Yeah, let's like this one. You see the difference is half lambda. You see, it is both of these are antiphase. This one go down, this one go up. You see, antiphase. But they end up in phase. Because the path difference is half lambda. The path difference, the extra distance, this one is only half lambda. So this one, if like that, it form a bright fringe. This one, it form a first bright fringe. First bright fringe. Because the delta L, I should sorry. Because the delta L is just half lambda. I form the first bright fringe, and then of course we can expect 1 plus half lambda, 2 plus half lambda, all those will become bright fringe. Understand? This is the conclusion I can make. Okay, for two coherent source, if it is a in-phase source, these two sources are in phase. To form a bright fringe, the path difference need to be m lambda, and the dark fringe is m plus half lambda. Okay, m plus half lambda. But for antiphase, it become opposite. It just become opposite. You see that? The bright fringe now use m plus half lambda, but the dark fringe use m lambda. Understand? That means what I can say is m lambda. M lambda means 0 lambda, 1 lambda, 2 lambda, 3 lambda, and so on. M plus half lambda means it is either 0 plus half lambda, which is the half lambda, or 1 plus half lambda, and 2 plus half lambda, and so on lah. Okay, that's the thing. So this is the difference between in phase and anti phase. The path difference just become opposite. Understand? Path difference become opposite. Okay, so this is the most important thing lah. I squeeze up everything. Okay, we will refer this in the young double slit, and also the thin film, and also single slit and diffraction grating. All the following subtopics all related to this thing. This is the, we can say this is the core idea to how to form the bright fringe and dark fringe for either in phase source or anti phase source. This is the most important thing I can say. Yeah. Okay. That's all for in phase and anti phase. Now I want to what I can say, this one. These are several very common terms to mention about bright fringe and dark fringe. In the questions, he won't specifically says bright fringe. He won't specifically say bright fringe. He won't specifically say dark fringe. Okay. Sometimes it give you other terms to guess it is bright fringe or dark fringe. Yeah, it give you other terms. So what are other terms for bright fringe? Bright fringe, sometimes we call it maximum. Yeah, maximum and or maxima. Why we say maximum and maxima? Because this one relate to the intensity. Do you remember the intensity? The maximum, because it has the maximum amplitude. For the intensity, because for bright fringe, it has the maximum amplitude for intensity. It has a maximum amplitude. It's related to the amplitude, the maximum intensity. Bright is the light is very intense. For the dark fringe, it has the minimum amplitude. I can say minimum amplitude. Minimum intensity. What I can say? Minimum intensity. That's why I call it minimum or minima. Minimum is a singular. Minima is plural. What I can say? Minima is plural. Minimum is singular terms. Singular. Many minima. We don't say many minimum. We say many minima. One minimum. One maximum. Many maxima. Many maxima. That's all. Okay. And then sometimes we the keywords for bright fringe. We also have of course constructive interference from the bright fringe. Constructive interference means it forms bright fringe. And this one, most strongly reflected light. Most strongly reflected light, or we can say most strongly sometimes reflected or maybe transmitted. Sometimes it's because of refraction, you see. Sometimes it's because of refraction. Sometimes we transmission means transmitted. We can say transmitted. So because we have light can be either reflection, or refraction. You see that? Light can either be reflection or refraction. So when it's reflection, we say it's reflected. When it is transmitted light, most strongly transmitted light, we say it is because of refraction through the glass. Refraction. Okay, so so the word most strongly, here, the word most strongly here, it means bright fringe. Most strongly reflected light. You can see the light. Sometimes excuse me. Sometimes you just say you can see the light. Can see the light. You already mean bright fringe. Okay. Excuse me. So for dark fringe, is either we say missing light, or we can say cannot see the light. Unable to see any light. Cannot see Cannot see. Why? Because the light is missing. Why is missing? Because it's already being cancelled out. It's already being cancelled. The light is already being cancelled. That's why destructive interference. That's why you cannot see the light. The light is missing. No light is reflected. No light is reflected or transmitted. Okay, that's all means dark fringe. Yeah, no light. Why see no light? Actually, there's light. There is light, but it's already being cancelled. It's already being cancelled because of destructive interference. There is actually light reflected. There is actually light reflected, but it's already being cancelled. That's why you you cannot see the light. You assume there is no light reflected. Okay, no light is reflected because it's already being cancelled. All right, that's all. Some common terms for bright fringe and dark fringe. All right, destructive interference. Yeah, excuse me for coughing. Yeah, frankly, I use a lot of times and effort to do all these videos. That's why I end up like this. Okay, hope that you can be patient enough to listen to my next video. See you again. Bye.